you can hear me okay now, and you can also see my current slides. Is that okay?
Yes.
Awesome. Let's go ahead and get started. So again, my name is Aaron Wilson. I'm a research scientist at the Byrd and Climate Research Center, and I'm also with OSU Extension as a climatologist. And so I get to work with farmers, gardeners, master gardeners all across the state as well, just thinking about weather and climate and the impacts that we're seeing on what we love and what we love to do. So really what I like to do is just generate some conversations about some of the things that we're seeing out there and some of the impacts on a personal level. You're going to hear me say personal a lot in this presentation because weather and climate are really, really personal. So in your lifetime, thinking about weather patterns changed. What have you noticed? Have you experienced impacts on your soils, your water, your crops, your plants? What about your stress level when you're out there working in your gardens and such? All of these are really good questions to think about as we think about the personal impact of weather and climate. Now, a little bit about my background. I grew up in Miamisburg, Ohio, so I am a Southwestern Ohio kid. When I was 3, though, we moved to Miami, Florida, and even at 3 years old, you're intimately aware of the power of hurricanes. And that's really where my love of weather began. Watching the interaction between the atmosphere and the ocean create these huge swells in the ocean as well. And I just was really hooked on what was happening. And a couple of years later, we moved back to Miamisburg. And of course, in 1988, we had the Big Dry, the big drought across much of the Midwest. Time magazine called the Big Dry. And that was enough to push me out of farming. That's my retirement photo there on the right-hand side. It was the last time that I was on a tractor, but certainly I was interested in plant impacts of weather and agricultural impacts, but was more drawn to the weather side of things. And then many of you may remember John Hope. He was the weather specialist hurricane specialist for the Weather Channel. This was Hurricane Hugo as it approached Charleston, South Carolina. My family lived in Charleston. This was in 1989, and just watching him communicate about those impacts was really impressionable on me. So as I always do, I start with talking about weather and climate. We think about weather, we think about these really high frequency changes in temperature. I think this week is a great example of what our weather can do. We can go from the upper 70s to low 80s, and then we can drop down with highs just a day or two later, just in the 40s. And so, this high frequency changes. And what we try to do as meteorologists is we try to develop patterns, right? We look for patterns in the data. And sometimes we have, we can see fast moving swirls of storms along the equator, in the Southern Ocean, pulses of thunderstorms across the tropical regions. This was supposed to be a video, but it's just kind of another glitch today. We're going to roll with it. But obviously, we start to see patterns when we can draw back and look at things from a broader distance. Now, all those high frequency changes in our temperature, wind speed, and moisture, over a long period of time, it develops what we expect to happen, and we call that our climate. And one of the ways we can look at weather and climate is, say you're out walking your dog, right? And the dog's on a leash, and that dog is going to be meandering back and forth, driven by some internal drives, right? If it's got really hungry and it wants to use to get a McDonald's wrapper up here, it can move in that direction, or a fire hydrant because it's got to use the restroom, something like that. That dog could be moving in a different direction than the dog walker. All right, so even though they're moving together and we still expect them to be in this location in a couple of minutes, that dog is going to take a meandering path. And so we can think of the dog as the weather, and you yourself, the dog walker, as the climate. So the climate path can describe the general terms, the path that the dog takes, but not precisely. And that's the way we can look at these two as an example. I talk a lot about power of weather. We talk a lot about extreme weather. We're not immune to extreme weather here in Ohio, certainly. We've had our 1913 flood, right? Southwest Ohio. This is Miamisburg in 1913. Before the levees were built up and down the Great Miami River, inundation of water. Really considered Ohio's greatest weather disaster. We have winter extremes, perhaps not as often now as we did in the 1970s, for sure. This is the blizzard of 1978. We have derecho. How many of you were impacted by the derecho of 2012? That's the bottom left figure showing the path of the strong line of thunderstorms. And then even last year in Southwest Ohio with the Memorial Day weather outbreak, tornado outbreak. Even the tornado outbreak we had 2 nights ago, you know, there's probably likely to be several tornado paths across Southwest Ohio. Just the power of weather in these extremes. So we talk a lot about the extremes. 2019, we're gonna talk a lot about last year just for contextual purposes. 2019, we had 14 weather and climate disasters that were at least $1 billion, okay? 14 of them. And they look a little bit different, right? Out west, we're talking about wildfires. In the southeast or Gulf states, we're talking about hurricane damage. Here in the Midwest, we're talking about flooding. And so different areas of the country experience these changes a little bit differently. Now, how are our extremes changing? The bottom right graph is showing the 1980 to 2019 year-to-date billion-dollar disaster events, and they've all been put on the same scale, a consumer price index adjusted scale. So that black line is what we've seen as a mean over that 1980 to 2019 period, about 6 per year. But all of our recent years, like 2011, 2017, 2019, 2016, 2008, are all in that 12 to 16 events per year. So we've seen a big increase in those billion-dollar weather and climate disasters. And one last introductory kind of comment here, talking about Ohio. If we look at Ohio's natural disasters between 2008 and 2017, we can see over $200 million of damage has been in rain-related disasters. Certainly tornadoes are up there as well. But Ohio has a water-rich climate, and so changes in our weather patterns, changes in that climate are likely to come through that water interface. And I think that's important as I start to move through more of the presentation. So let's take a look at 2019 as just an example here. You know, we had temperatures that were above average across the state, but not everywhere. So wherever you see gray, these were temperatures kind of close to average. Here in Southwest Ohio, we were generally 1 to 3 degrees above average for the year. That ranks as 12th warmest for the state of Ohio since 1895. We use 1895 in our records because we've got long-term observations across the state since that time. So it gives us more confidence in this period, this 126 year period. So it's the 12th warmest. If we look at our moisture, our precipitation, it was the 6th wettest on record since 1895, spanning anywhere from about 30 inches of rainfall up near Toledo, 35, 38 inches of rainfall near Toledo. Down in our region here in Southwest Ohio, we were generally above 40, many locations above 50, and some of them above 60 inches, right? So it was a wet year. It was certainly a wet year. We can see across Southwest Ohio, areas picking up 12 to 18 inches above average. That's a lot of rainfall, right? But it wasn't evenly distributed across the entire year, as you know, and that can also have some impacts, and we'll talk about that here in a second. Now, the previous graphs I showed you are more like the climate, right? They're the averages. But this is what weather looks like, right, on a day-to-day basis. So each of these gray lines show the high temperature and the low temperature for that day and how close to the record high or record low they were based on those dark red or dark blue lines. So let's take a trip back. We're thinking about last winter. What were we dealing with mid-January? Huge cold air outbreak, right? We call these things polar vortex events. I like to say affectionately known as. I tend to like them because I love wintertime. I think most of you realize meteorologists love the snow most of the time. I think that's why the forecasts get overhyped just a bit, but that's off topic here. But we had near record cold in a warmer than average winter, right? So the winter was warmer than average, but we had a few days of extreme cold. That's that dog, the motion of the dog. Let's jump ahead to the fall. We think about our first week of October, record highs in the mid 90s, 96, 97 degrees, the first week of October. And then by the first week of November, we were in the single digits. So this drop from the mid 90s to the single digits was the fastest, right, drop in our temperature in the last 125 years. And then we know what's happened this winter. It's been very warm, and I'll show you that toward the end of the presentation today. So a lot of variation, a lot of variability went into describing the climate graphs that I showed you on the previous slides. What about the water? It rained a few days, right, in 2019. So this is the daily rainfall. And by the way, this is the station in Northern Kentucky, Cincinnati Airport. If we look at the number of days, rainy days we had last year, and if we look a little closer at the number of events that we had at least an inch to an inch and a half of rain, there were 16 of them in 2019, and 2 events over an inch and a half. So in 18 days of 2019, we picked up 45% of the annual precipitation of 52 inches. And by the way, again, that's a good 10 to 12 inches for that site above average for an annual basis. Right? So there's something about the nature of the precipitation that's changing as well. And again, we'll get into that as we get into the climate section. So kind of just stepping through some of this, ignore the typo in the upper left here, but we had a very wet winter across Southwest Ohio last year, well above average. It was the 11th wettest for the state. We had frequent intense freeze-thaw cycles throughout the state as well. We went into the springtime, and again, there's some regional differences across the state. For the state in general, it was only the 32nd wettest March through May period. But if you asked folks in West Central and Northwest Ohio, they were much, much wetter than that. St. Mary's, Ohio, for instance, over 20 inches of rain just between March and May. That's over half their normal yearly rainfall in just 3 months. Multiple locations of at least 15 to 20 inches of rain, 20 to 26 days of at least a trace of precip in the month of May. So really limited. When you hear about all the agricultural impacts in Northwest Ohio, this is the reason why, right? So not a lot of field work. So if we can look at some other extremes, right? How wet was 2019? So we can look at a 12-month period and look at our statewide ranking. So whenever you see a state ranked at 124 in this record, this was the wettest period on record. So we're looking at June of 2018 through May and comparing it to all other June through Mays on record. It was the wettest June through May 12-month period on record last year, okay? We had our 5th wettest June for the state of Ohio, so we repeated that mark. So now our July through June was the wettest on record. And even though here in Southwest Ohio, we know what happened late summer and early fall, we still had the wettest August through July and the wettest September through August on record for the state of Ohio, okay? Back to back to back to back, wettest 12-month periods on record. That's extreme. That to me would classify as extreme statistics. So we had a lot of impacts last year. Our soil moisture was really in the 95th to 99th percentile across Southwest Ohio for a large portion of the year. We had a tremendous amount of water flowing across the surface, especially last spring in Northwest Ohio. We had the record cumulative amount of rainfall of runoff coming down the Maumee River going back to 1899. So we know about these impacts on our soils and streams. And then what happened, right? In places like from Cincinnati to northern Miami Valley to Columbus that had picked up nearly their entire year's worth of rainfall in the first 6 months of the year, we shut that valve off. And we went to less than half the normal precipitation in many areas across the rest of the year, right? So we only had 12 or 13, 14 inches of rain the rest of the season. Now it's still, again, going to down as the 6th wettest year on record, but these interseasonal changes have big impacts, right, on gardening, big impacts on what we do. We had our warmest September on record in 125 Septembers, right? So by the October, we were dealing with moderate drought conditions in 26% of the state. In the same year, we went back to back to back to back, wettest 12-month periods on record. Folks, I don't know how you define extreme, but this is extreme swings in our hydrologic cycle, right? This is what we've seen. Now, typically, this is where I would ask you and ask folks, you know, how did the weather of 2019 impact you or your local community? I think given the kind of disruption that this morning has brought to get this started, let's go ahead and save that. And I'll make sure that we've got at least a little bit of time at the end to talk about some of these questions. But be thinking, you know, what were the 2019 impacts on you or your local community, okay? You can also feel free to put them in the chat and we can think about those as we get to the end of the presentation. Now, from a global standpoint, let's kind of broaden this out now and talk more climate from a global standpoint. 2019 ranks as the 2nd warmest for the globe going back to 1880. Again, numerous stations across much of the area back to 1880. The second warmest. What's even more astounding is for the globe, 9 out of the top 10 warmest years have all occurred since 2005, and the 5 warmest years are all the years since 2015, okay? Just to give you the kind of warmth that we're seeing. And this statistic always blows me away, that if you were born after February 1985, you have never experienced a cooler than average month for the planet. It's an astounding statistic. The planet has never been cooler than the 20th century mean since February of 1985. Okay, so just to put that kind of in perspective of what we're seeing. The animation in the upper right is just showing you the departures, the differences between that 20th century mean as we move from the late 1800s to today. So we see an enormous amount of the area warming across the globe. Certainly different decades were warmer and cooler, right? We think about the Dust Bowl in the United States and the warm conditions we saw in the 1930s, or the cold conditions we saw in the 1970s. Regionally, you get these differences, but across the globe, we've seen these accelerated warmth across a lot of the land surface. I want to go through this briefly, but we always think about, okay, what's causing the climate to change? We've got natural variability. We know we have changes in the incoming solar radiation. On a short-term basis, these are very small changes. And as a matter of fact, over this most recent warming period we've seen, the amount of solar radiation is decreasing. It can't be a likely candidate for our changes, although it does have a big impact on longer scales, as you'll see in a moment. What about Earth's surface characteristics? As we get more urban, right, we trap more heat within our cities. Our cities tend to be warmer than the rural areas, but we can look at trends in the rural areas and trends over the cities, and those are increasing similarly, right? Composition of the atmosphere, we're going to come back to that one. But back to the solar radiation and the variations in the Earth's orbit, you know, there are natural cycles out there at play, right? So these are 3 of our natural cycles. These are periodic motions in Earth's orbit that really give us a predictable amount of variation in Earth's climate. Earth is going around the sun, sometimes more like a circle, more times like an ellipse, right? So that will dictate how much radiation the Earth is receiving during particular seasons. We wobble through space, okay? It's 26,000 year cycles. I know I typed 23, but it's 26. So right now we're closest to the sun because of the precession in January, but that's not always the case. And then we change our tilt. And by changing our tilt, when we've got less tilt, we get cooler summers, right? So if it's snowing in Canada and in the north, the Arctic, and the summer is cooler, that snow can last year after year, and that's how you start to build ice sheets. So over tens of thousands to hundreds of thousands of years, that's how Earth has developed these ice sheets that are currently melting at accelerating rates. Back to the composition of the atmosphere. It's pretty straightforward what happens. Okay, and just a simple illustration here. We've got sunlight coming in, visible light. It's shortwave, high frequency radiation. Everything on Earth, if it's not highly reflective, absorbs that energy and then transforms it to infrared light, heat, long wave radiation. We have awesome greenhouse gases in our atmosphere, water vapor, carbon dioxide being the largest. That visible light does not impact those particles at all. But that infrared light coming off the surface, those greenhouse gases absorb that energy, and when molecules absorb energy, their temperature increases. So it's a good thing that we have a certain mix of greenhouse gases in our atmosphere. It allows for the type of what we hear a lot of times about the Goldilocks atmosphere. That's because of our mix of water vapor and carbon dioxide. But as we add more of those particles to the atmosphere, again, they don't care about the visible light, but more of that, they're greedy, and they suck up all that, more of that infrared light coming off the surface of the Earth. They emit that and absorb it between the particles, and less energy escapes to space, and our temperatures increase. And that's how changing our composition of the atmosphere contributes to what we're seeing. Again, 60 degrees of our current temperature comes from our makeup of water vapor and carbon dioxide in our atmosphere. We would be 60 degrees cooler without it, but they've both increased drastically over the last 50 years. We know when we started measuring directly, CO2 in 1958 was around 310 parts per million. We're now over 410 parts per million. So that's 100 parts per million increase in 60 years. How does that compare with those Milankovitch cycles that we've seen, that I showed you before? This is what the natural cycles look like throughout the last 800,000 years of Earth history. We know during our warmest periods, our CO2 concentration was around 280 parts per million. During our cold periods, when we had ice sitting here in Ohio, we were at 180 parts per million. So we go up about 100 parts per million, and it takes upwards of 10,000 years to do that. We've done the same, the equivalent in 60, right? This is the human footprint. And that hasn't been seen in our record going back 800,000 years. And that CO2 remains in the atmosphere for decades to millennia. 80% of it is still there 100 years from now. So when we think about this current pandemic, and we know that the CO2 levels have drastically dropped, I get a lot of questions, well, this should really change climate really quickly. No, because all of the CO2 that we even started burning at the start of the Industrial Revolution is still in our atmosphere, right? So that's just something to think about as we move forward. But it's much more than just about temperature. There are a lot of feedbacks, and that's what's critical to what's happening here in Ohio. You know, our increase in temperature is certainly melting glaciers and ice sheets. That's leading to runoff and sea level rise. But it's been a long time since Ohio's had an ocean. So sometimes we don't think about those direct impacts. One of the things that we're seeing is an increase in that water vapor, an increase in that humidity, right? And the amount of water vapor that's in the atmosphere. And those two, between temperature and the rise in the water vapor, is what's contributing to our changes here locally. So we can think about the Arctic sea ice loss, 13% per decade. Does that have an impact? You know, these are distant, what we think of distant locations. The equivalent of 4.5 million Olympic-sized swimming pools worth of water melting off the Greenland ice sheet last August in a single day, right? We think about this sunny day flooding up and down the coast, inundation of water inland. All of these changes that we're seeing that are particular to certain places, right? But what about our local changes? We've heard a lot about wildfires in Australia and the changes that they're seeing. Our wildfires here across Alaska, the Pacific Northwest, and California of late, an increasing wildfire strength, severity, and season length. That is the personal face of the changing climate in that region. If you go to southeastern US, we know about the hurricanes, the intense hurricanes, the strongest storms increasing in frequency and duration. And then here in the Midwest, it's the extreme heavy downpours, right? The strong heavy downpours and that changing characteristic of a rainfall that is our big threat here. So we think of climate change as a threat multiplier, right? It makes everything we do harder to do it. It makes our plant selection, our gardening, the stress level, the amount of rainfall or lack of it and the watering needs that much harder because of the changes that we're seeing. And it's very, very personal. It comes down to certain regions across the globe. So we can look at seasonal differences in warming. One of the things we know is that our warming is most widespread across the US and greatest in our winter. So here in Ohio in the Midwest, our winters are warming twice as fast as our summertime. So this set of graphs really is showing the changes in our different seasons of temperature from 1950 to 2012. It's a little bit old here, but it proves the point that our winter and spring temperatures across the Great Lakes region are warming much more rapidly than our summer and our fall temps. If you go into the upper Midwest, it's upwards of 5 to 6 degrees Fahrenheit changes just since 1950. Here in Ohio and in Southwest Ohio in particular, we're looking at 1 to 2, 2.5 degree wintertime increases, a little bit more in our springtime, more like 2 to 3, 3.5, and then about half of that when we get into summer and the winter, or summer and the fall. All right, so again, the changes in our temperatures are a little different depending on what season we're looking at. We can look at our annual seasonal differences in precipitation as well. So across the globe, we've seen about across the United States, we've seen about a 4% increase in our rainfall. Here in Ohio, it's more like 5 to 15%, and it's very seasonally dependent once again. So here are our 4 seasons in the precipitation changes. In wintertime, we're actually drying over this 1950 to 2012 period. So our winters are becoming drier. Down here in Southwest Ohio, our summer mean precip hasn't changed that much either. It's close to zero. It's between 0 and 7%. But our big changes have been happening in the springtime and the fall in terms of our rainfall. and especially in across much of central, eastern, and north central Ohio, where we have a 30% increase in the fall precipitation, right? So there's a lot of seasonal changes, seasonal differences that are taking place in our variables, such as temperature and precipitation. So if we look at our Ohio's annual departure from average, that long-term mean of 1980 to 2010, we can see that the recent decade to 2 decades here have been the wettest on record over the last 125, 130 years here in Ohio. But again, it's not just the amount or the seasonal changes, but it's also the intensity of those changes. So we can look at the observed number of extreme precipitation events defined here as greater than 2 inches since 1900 to 2014. And we can see since about the mid-1990s, this stepwise change in the number of extreme precipitation events that we see. There are 3 other peaks in our record here, 1913, 37, and 59, fall within those peaks of Ohio's record. And those were all what for Ohio? These were flood years, major flood years. So we know that flooding is much more than just a precipitation story. How are we developing our neighborhoods, our cities, even in the rural areas as well? How are we storing that water? How is that water flowing over and within the surface? What do our streams and our outflows look like? All of that's going to help predict whether flooding will occur. But certainly from a precipitation standpoint, our regime now is for a persistent flood threat, a flood risk. So that's an important piece to this study. So if we think about the rainfall intensity, this is an example. It's a little bit out of Southwest Ohio, obviously, but I've got similar ones across the entire state. But just looking at this rainfall intensity for 20 stations across northern Ohio, and we're going to bend them back to 1950 in 5-year periods. Okay, that's what the x-axis is. And this is the total number of events where we see greater than 3 inches for any one location. So you can see it's relatively flat. It's hard to see a trend. 3 to 4 inches is generally the maximum that we see in a single event or a single day event, okay? But if I start stacking some of these other totals on here, so this is everything greater than 2.5 inches or greater than 2 inches, we start to see a trend develop, especially since 1960. Where we're getting more heavy events as part of our annual total of events here. So that now by the time we get to the later part, we're dealing with about 45 events every 5 years. So that's 9 or 10 events a year of at least 1 inch of rainfall. Cincinnati had 16 1-inch rainfalls in 2019, right? So as an average here, we're seeing about 30% of our annual rainfall falling in 10 days out of the year. So it feels wet, it is wet, yes, but the character of that rainfall is changing, and that can have impacts on our gardening and our plants and other issues as well. So we can round back now to, looking at Ohio's climate, the top 10 warmest and top 10 wettest years. So I'm going to highlight the years here that 4 out of the top 10 warmest and 6 out of the top 10 wettest have occurred since 2003. Right? Again, this record goes back to 1895. And if we look at 7 of the top 10 warmest and 8 of the top 10 wettest have all occurred since 1990. So we're living in a much wetter regime now than we did in the mid-20th century, and our great-grandparents and grandparents did even in the early part of the 20th century. So much wetter regime these days, and a warmer regime as well than what we saw in the past. Okay, so that was a lot of information about how things are changing. I think it's important to kind of summarize that, yes, our temperatures are changing, but seasonally, that depends on where you are, regionally around Ohio as well. Precipitation increasing, but not just in the amount, but in the seasonal changes and the intensity of the event. So there's a lot of details, the details matter, especially when we think about our plants, our soils, and our gardening work. So if we look out into the future, I think right now we're all sort of getting a primer on models, right? And how models depend on the information that are going into models and the assumptions that are made in those models. So as a modeler myself, I will always tell you all models are wrong. Some models are useful. okay? And they're only as useful as the data and the assumptions that are going into them. Now, from a scientific standpoint, our best models for future climate are displayed, the results are kind of displayed here for the Great Lakes region. So when we project out to kind of a 2040 to 2070 average, again, think about a mid-21st century mean. We're talking about temperatures in Ohio 4 to 5 degrees warmer than what our contemporary climate is today. And when we think about the rainfall, we're looking at more like 3 to 5 inches of rain more per year than that typical average that we've seen in our contemporary climate. So when we see years like last year, 52 inches, or 2018, right, when we had much more than that, some locations east of Cincinnati with upwards of 70 inches of rainfall for the year, that is likely to become more common than what we've seen in the past. Okay, so it's very important to keep in mind. I was hoping to show you today some of the extreme changes. One of the things we've seen in summertime is our maximum daytime high during the summer has actually cooled over much of the Midwest. So we're not seeing as many 100-degree days that we did in the mid and early part of the 20th century. Again, as we have more water vapor in the atmosphere, that allows for those daytime highs to be capped a little bit, and we don't get as warm as we would. But what's happening at night is that water vapor is keeping our temperatures at night warmer than they would be. So our summertime warming is really occurring during the night, where we're seeing a lot more 70 and 75-degree days. Now, if we look at the change in number of days where we stay above 90 degrees, we're still projecting to add another 40 to 60 days in some locations, especially in Southwest Ohio, on the number of days where we reach at least 90. So 92 is hot, right? And if we're having more frequent heat waves, which we have more 90-degree days, you know, it may not be 100, but still, when we're thinking from a plant perspective or our soils or gardening and horticultural impacts, that's going to have a big impact, I would imagine. If we think about the change in the number of nights, and this should say that's below 32 degrees Fahrenheit, falls cooler than our freezing, we're looking at another 20 to 40 days where we don't fall below freezing. Now, some people might say, hey, sign me up. That sounds like an awesome winter. And you know, more mild winters are often more comfortable for folks. But if we think about from a plant hardiness, we think about our natives, if we think about pests and disease and weed pressure, having fewer overnight cold temperatures in the wintertime can be detrimental, right? So that's you know, some things to think about as we move forward. And we're also seeing most precipitation is going to be occurring with the heavier rainfall events over 2 inches. So we see all of these things coming together. We see a seasonal redistribution of our precipitation, where we have wetter falls and wetter winters and wetter springs, but then we have drier summers, okay? And so if we think about from a growing perspective in the growing season, where we're seeing a lot of rainfall early in the season and late in the season, but not enough on our growing crops or our growing plants, that could be an issue. We could think about water shortages, seasonally dependent, because not all seasons are changing at the same pace. So I've been asking now for the last year, what if this is our new normal? I think in general, that might be a pretty big philosophical question given the state that we're in these days. But from a weather perspective, thinking about our new normal, I show you 2019 and think about these recent conditions because it's fresh in our memory, right? But if we look at the conditions that we saw in 2019, like a longer growing season, you know, we're averaging now 9 to 10 days more than the mid-20th century where we're seeing a longer growing season. Warmer temperatures, especially at winter and at nighttime, in particular during the winter and summer. Higher humidity levels, more rainfall, more intense rainfall events, more autumn precipitation. All of these things that we've seen in 2019, and we saw them in 2018, and some of us saw them in 2017, and many other years over the last 20 years, this is what we see in our long-term changes and long-term observations. So Ohio's climate is migrating. It's on the move. And if we think about what we can kind of conceptualize as the 2003 climate over Ohio, our winters are moving more toward that of Virginia, right, and North Carolina. And our summers are moving toward one that's more like the South Central Plains, the Arkansas, or even East Texas, okay? So our climate is creeping toward what those climates are like these in our contemporary period here. Now, it's not all negative, right? It doesn't have to be all negative, and it's certainly that is dependent on what the actions that we take. And while there are a lot of pressures and a lot of stress from what we're seeing, I think it's also good to mention what opportunities does this open up in terms of plant selection or things that we weren't able to do before. Certainly that's on the table. But you know, how can we respond? How can we personally respond? How can our local community respond also to these changes? There's a very good resource out there, and this is in the specialty crop area, which you know is kind of a niche, obviously. But I think it's got some really great information that all of us from a horticultural perspective can use. If we're thinking about, you know, this key group that came together in 2014, a lot of specialty crop growers, Ohio State station directors here, experiment station directors, thinking about these things. And there were 85 key issues that were associated with climate and the production systems that they were bringing up. And they've kind of completed the statement: one way a changing climate and extreme weather events affect fruit, vegetable, and other specialty crop production in the upper Midwest is ... Okay? And they ranked these statements then for importance and grouped them together by similarities. So some of the 9 priority areas that emerged were things like pest and disease, marketing and risk, the amount of water, just climate and weather in general, and then other things about changes in labor, changing opportunities there, but also the vulnerabilities. So I really appreciate the way these were structured and tiered, and then thinking about the top statement from each of these. Again, thinking about our new invasive insects and pests, disease, and weeds. What impact is climate having on those? From a climate and weather, fluctuations in our spring temperature. I mentioned the extended growing season, but you know, a lot of times we're seeing, we didn't this year, but we see these fall springs where we warm up a lot in February and we break dormancy for some things, and then we're susceptible to late season freezes. We've got a situation right now where we've got a very advanced phenological state because of our warm winter and warm spring so far. And now we've got some healthy is not the right term, but some really strong confidence and some really cold air coming down across the region relative to this time of the year. That sets us up for these types of risks as well. Some more of the temperature impacts that perhaps you're thinking about, from how are you impacted, how is your community impacted, the stress on humans out there working in the gardens, also livestock for those producers. We intensify our urban heat islands. So if we think about gardening within the city, or, you know, that can be a mitigating impact, having more gardens and being able to limit that. So we think about increased need for adequate cooling. We're going to get into a little pollination impacts, things that are sensitive to high temperatures, reducing productivity or reducing the quality. We hear that a lot, reducing quality. I keep coming back to increased weed pressure, insects. A lot of our insects and weeds that we deal with today it's not as if they just meandered into Ohio because of a changing climate per se, but they were brought here, right, with shipping and transportation. But then they find the climate to be reasonable and growing more reasonable so that they can flourish. So it's a combination, again, about climate change as a threat multiplier, making things we do a little bit harder. Some other issues that I think with growers, you know, higher average temperatures, shifting precipitation patterns, causing some plants to bloom earlier, right? Creating unpredictable growing seasons, for instance. We often hear a lot of our attention on invasives and non-native plants, and these ranges expanding, making them more apt to take over and outcompete our native species, for instance. Native and iconic plants, you know, how much longer will they be able to survive? Whenever I'm in Columbus, I like to talk about the buckeye, right? And its viability into the future. Important connection between pollinators, breeding birds, insects, all being disrupted. You know, pollinators such as hummingbirds and bees arriving too early or too late for the flowers on which they usually depend upon. Leaf wetness duration. Again, if we're more humid and wet for a long period of time, the plant disease epidemiology Impacts on soils, from an increasing temperature standpoint, thinking about reduction in moisture content, loss of organic matter, increasing rainfall makes us more susceptible to erosion and runoff. We think about extreme precipitation risks, right? Our flooding risks, health risks to floods, mold, exposure to non-point source pollution. Intensity means more runoff and more potential contamination, right? And again, these summer shortages on water because of our summer droughts and drying winters, even though we're seeing much more precipitation. Here's another great resource here. It's actually out of Australia, but thinking about horticultural adaptation, changes to our irrigation systems, hybrids with greater heat tolerance, for instance. With water in our off-season, do we have the ability to increase investment in our storage capacity, dam storages and tank storages? Watery efficiency at night, switching to night and drip, and probably a lot of actions that many of you have already adopted, are having impacts in terms of becoming more resilient to these changes that we're seeing across the region. So I think soil and water health and conservation are all good nexus points for thinking about resilience to these changes from a climate perspective. What strategies slow the progress of water from our gardens into say the storm water, or what strategies improve the quality of soil, improving our health and our plant health and water storage capacity. I think these are all great conservation and soil and water health strategies that one might develop. I'm never prescriptive, this is just me brainstorming and collecting information about potential impacts. And I know all of you out there certainly have thought about other ways that you're personally impacted by all of this and how you might build resilience. But these are just some ideas and some suggestions from within the community of thinking about how we build that resilience. So this is kind of where the presentation, the formal part of the presentation will end. I do have a few slides for those that are interested in kind of the near-term outlook now for the spring, again, talking about that cold weather. But this might be a good place to kind of stop and maybe take a few questions. That way, folks that do have to get off the call really soon can go ahead and do so. So I'll send it back to you, Gigi. Thank you, everyone, for really working with me this morning as I got this stuff underway.
If you have any questions, go ahead and add them in the chat box and we will get those to Aaron. If you would like to say your comment, just raise your hand and I'll unmute you.
And Gigi, you have emails of those that registered?
Yes,
or not?
Yes, I do.
Okay, because I'll make sure that the copy to the slides is provided. That way everybody can get a copy if they wish.
Okay.
So I can see some of the questions coming in. Yeah, I'll make sure I get you that website. Should we start planting more plants for zone 7 versus zone 6? Not being the horticultural expert, again, just offering the climate, I think down the road, we're going to see those shifts, but I think we've recently shifted, right? Mainly from some zone 5 to zone 6. Are you 6B, right, Gigi, in your area, or 6A? Yeah, 6B.
Yeah. B.
So I would lean on, the USDA and the Arbor on those recommendations. That's not something I'd feel comfortable with, obviously. The one thing to keep in mind, too, is that as we transition, we still get these extreme events, right, in the wintertime. So and I've heard stories of folks that have already switched to some plants, and then, every 1 or 2 or 3 years, those plants aren't going to survive because it just gets too cold in that particular, time for that plant. So that's, yeah, definitely something I think that will come down the road as we continue to shift. I mean, just looking at the shift toward an Arkansas climate, what do they grow, for instance, that we don't grow here? That's certainly something to think about. Right. You're right. One extreme winter kills zone 6 plants as well. So it's a very cautious especially when we see the variability, and something maybe I didn't hit so well, the variability in our wintertime temperatures. Yes, it's getting warmer, but again, seeing more of these extreme cold air outbreaks in a warmer than average winter just stacks those risks from a horticultural standpoint. All right, so why don't I go ahead and share the last couple of slides here just from an outlook perspective, and keep your questions. Actually, I can answer this one twice. Is this limited humidity? So the question is about, unclear why winters are warming twice as fast as the summertime. Is this limited by humidity in the atmosphere due to changes in ocean currents? So it's largely a driver in the atmospheric humidity, right? So overall, we've got more humidity, higher water vapor content. So during the winter time, that's going to keep not only our overnight lows warmer, but also our daytime highs are warmer as well than they would be under clear skies, for instance, when those temperatures can really drop. During the summertime, again, it has an opposite effect between nighttime and daytime. At nighttime, it's going to keep your temperatures warmer than average. During the day, a little bit cooler than they would be, because all of the energy is going into evaporating the moisture and not into directly raising the air temperature. So that's a really good question from Jennifer there. Have we had a change in the wind? That is a common question that I get about wind. There's there's a little bit different ways of distinguishing it. We can talk about mean wind patterns. This idea that our westerlies, most of our winds flow from west to east, have actually slowed down a little bit on a general sense. And that's allowed the jet stream to really stretch out, meaning we get warmer air surging into the Arctic, cooler air plunging down into our region, and then storms tend to move a little slower across the area as well. So there's an active area of research in that. In terms of the local winds, I would say right now I can't provide that information, but it's something that I'm looking into, just because anecdotally there's a lot of questions coming up about this, that it feels or seems windier, especially in our February and March, even during the windier time of the year, and throughout much of the winter. So I would say stay tuned, catch a future presentation, and I might have a little bit more on the wind speed there. Okay.
There was a question earlier in regards to recommended website for accurate past weather information.
Yeah, so past weather information. What I tend to use, I guess that depends on how far past. So all of the data that I use it's NOAA driven data. So it's from the National Weather Service. It's from NOAA. We have some great regional climate centers out there. Here in the Midwest, we have what's called the Midwest Regional Climate Center. If you look up, I think it's MRCC. Let me see. I'll try to type it in here. MRCC.illinois.edu. Illinois.edu. I'll make sure I get that to you also in the email with the slides. But look up the Midwest Regional Climate Center, and you can find some great information. They really tailor it to anyone can use under different topics, drought topics, agricultural topics, different topics from a climate perspective. You can look at freeze and frost dates that are typical or what we've experienced this year, for instance. And again, looking at that past information. So it takes a little bit of practice, I think, using the website, but it's a really good user interface for all of the National Weather Center data. So. Okay, was there any others that we saw?
I got one from a participant. He sent it to me privately that I'm putting in here, but it's about a Hold'em Arboretum has a great page devoted to what trees to plant going forward.
Mm. Yeah, and God, I can't remember the the guy's name. He works with Davy Trees, and I mean, I didn't really hit on the arboriculture. If you think about this is really a long-term game, right? We're planting trees today that we're thinking about their lives 30 to 50 years from now. So yeah, you've got the site on there. That's another one. Yeah, Dan Herms. I know Dan as well, so he does a lot of that work and climate-related work on horticultural as well. So these are all excellent, excellent resources for our community out there. All right, Gigi, is it okay to continue just another 5 minutes, you think?
Yep,
okay.
That's fine.
So I want to provide you some slides in terms of our outlook right now, because, you know, I mean, no better than the present time here to think about what we're going. So hopefully you can still see the slides. This past winter was our 5th warmest on record, again, going back to 1895. So most of the temperatures across Ohio were between 2 and 5 degrees above average for our December through February period. We did have a wetter than average year. It was the 22nd wettest on record, especially wet across West Central Ohio and parts of the Southwest, although this kind of looks like we skipped over, right, I-71 a little bit. But in general, it was wetter than average. Again, 5th warmest and 22nd wettest on record. So advancing, really coming out of the wintertime with advanced phenological states. More recently, this is the 7-day, 30-day, and 60-day comparisons to long-term averages. I kind of want to draw your attention to the last 30 days. Here in Southwest Ohio, we were generally 4 to 6 degrees above average over the last 60 days, or 30 days, and about 2 to 3 degrees above average over the last 60 days here. So we've got some cold air right now that's kind of gotten into place, but this is on the heels of very warm temperatures throughout winter and early spring. So that's why I think there's some concern from a horticultural standpoint. Parts of Ohio have been very wet over the last 30 days. I know here in Central Ohio, we've had upwards of 5 to 8, even 10 inches in some locations. So kind of this swath right here in the last 30 days. Here in Southwest Ohio, again, looking at 4 to maybe upwards of 6 or 7 inches of rain over the last 30 days, which is well above average over that period. One thing, again, I want to stress about, 2019 is so fresh in our minds because of how wet, extremely wet it was. Again, this time last year, we were sitting really in the 95th and 99th percentile in soil moisture. This year, we're sitting in the 80th percentile or above. Now, that still means that we're wetter than 80% of our historical record at this time in terms of soil moisture, but not quite as much as 2019. That's because precipitation has been a bit lower for Southwest Ohio. The temperatures that were warm during during the winter have allowed water to flow off the surface. So probably some of you dealt with Ohio River flooding this early or late winter, early spring that we didn't have last year as much. And then we were much drier this past fall with our drought conditions than we were in the fall of 2018. Rainfall for the week ahead, this is a little bit outdated, but we're generally looking at about 1 inch or so. That's kind of normal or typical for this time of year. So we expect things, even though they're not as wet as last year, in some areas, many areas of Ohio, there in Southwest Ohio, we're still going to keep things pretty damp. And the concern really is in the next, starting basically yesterday through about the 21st or 22nd of April, our probability from the Climate Prediction Center of below average temperatures really enhanced. It's really high probability that we're going to be colder than average. So we're talking averages right now should be in the mid 60s for highs and in Southwest Ohio, low to mid 40s for our overnight lows. The problem is this doesn't look like it's an in and out scenario, a quick cold snap. This is a 10 day to 2 week period of colder temperatures. We had our frost and freeze warnings last night. We've got them up for Southwest Ohio. National Weather Service more specifically has them up for our area again tonight, as temperatures may dip anywhere from the upper 20s to low 30s. But I think we're going to see frequent days over the next 2 weeks where we can see those cold overnight temperatures, but even daytime highs that are going to struggle in some of these days to get out of the 40s here, even in Cincinnati and Southwest Ohio. So confidence is growing, a major cold air outbreak relative to this time of the year. And I think it poses some really high risk to some horticultural assets, depending on what you're seeing out there. And then if we look out through the rest of our spring, the Climate Prediction Center is really calling for above average precipitation over the Eastern Corn Belt region and over the Ohio Valley region. So we think we're going to maintain, again, our wet soils and wet conditions, though I do think that our conditions will warm after we get through this period here, mid to late April, we'll start turning the tide on our temperatures. And we have pretty high confidence that much of the rest of the spring will be above average in terms of those temperatures as we see it right now. So I wanted to provide that with you because it's some practical guidance, you know, as we're heading out over the next couple of weeks, more so into our gardens. Thanks, Gigi. You're on mute.
Yeah, I am. Thank you, Aaron. Very good information for us. Of course, anybody in the realm of agriculture, whether it's horticulture or agronomic, we are all looking at the weather and paying attention to what's going on and trends that are coming about in regards to that. So actually, is there any questions? I will unmute you guys, and if there's any questions, otherwise, have a great day. If you are on here today, you're signed up for next week's. But if you have friends that want to attend, please make sure that they get on the registration and get signed up so I can send them the email just before we get started.